Dear viewers, welcome back. In the last session, we talked about database, the need of database, and in this situation we create database. And in this session, we are going to talk about the major difference exists between DBMS and operating system. If you want to have a database, then we need to have a query for it. Whenever we issue a DDL command to create database, how it gets stored in the memory? That's an important question we need to have here. Whether DBMS alone is enough to store the database into the memory, or it seeks the help of an operating system to get this done. Many would argue that yes, DBMS has all the potential to create the database and push the database into the memory. Yes, it can do it. But in many other contexts, it seeks the help of operating system too. Say for an example, when memory is get overlapped or the memory has been referenced out of the range, in all the cases DBMS cannot do this purpose on its own. It seeks the helps and leverages the process and get it done through operating system. The role of operating system is very important in deciding the memory slots for storing the database. And whenever you want to select data from the memory, secondary memory, in such cases, the role of operating system is also very important. DBMS in this manner, in this fashion, seeks the helps. So the role of DBMS alone is not deciding in storing or retrieving the data from the database. In many of the cases, operating systems also helps to achieve the task. Now, who is controlling what over here? Whether DBMS is controlling operating system or operating system is controlling DBMS. Neither of that is doing it. DBMS is not controlling operating system, or the operating system is no way controlling DBMS. Both are two different extremes on its own. But if you add a DBMS has the full potential of managing and controlling its own data. Its data. It knows more about structure. DBMS knows its database structure, and it also understands what is the access pattern for getting it done. In what way the SQL query fetches the data, or what way the SQL query pushes the data. So that can be done by DBMS alone. In this aspect, operating system role is none. In pushing the data into the memory or retrieving the data from the memory, the operating system role is none. But in deciding the memory slots of where to store your data, in deciding the critical conditions of overlapping and paging replacement, in such cases the operating system helps DBMS to get through the process. So that is where the important difference lies. Now come back to the real optimization between DBMS and OS optimization. What are the roles that majorly take by DBMS? Load control, buffer management, access to external storage, and scheduling of process. Even scheduling of process can be done by the DBMS itself. Whenever you have a huge task of pushing the data into the memory, yes, DBMS can do the task. Buffer management, all your data is stored in a temporary memory, that is called what in-memory database if you go for the larger context. It stores and it can be accessed by DBMS itself. And whenever if you have your data at remote servers and if you still want to access it, then that can be done through DBMS alone. And whenever we have more applications requesting for database, and that can also even managed by the proper scheduling by DBMS. So in where the operating system role comes in, many of the tasks even DBMS can take over. But in some critical conditions, when the application and DBMS overlay with one another and wants to get a proper trade-off between two, in that case the role of operating system is somewhat important, and the scheduling algorithms or memory management scheduling process can be done through operating system. Then what is the major difference between these two? What is the major difference? DBMS has the full potential to know their workload of the data, and DBMS can predict and shape the access pattern of your query. This we called as what? Query optimization. That means given an SQL query, the system may know the access pattern of the query. That means in what way the query can be enhanced, in what way the query outcome can be very easily fetched out, and how efficient it can be done, how to leverage the whole process, and all the things can be done by DBMS itself. And DBMS knows the mix of queries, that is on the fly it can pre-compile the queries and execute it. That is somewhat static or more dynamic. Either thing is possible in DBMS. And DBMS knows the exact contention rate between the queries. And in overall process, OS do the generic optimization. DBMS do the specific process and specific optimization, and OS does the generic optimization. That is why there are two types of operating system. One is general purpose operating system, another one is called what? Special purpose operating system. The special purpose operating system is called as what? RTOS, which is dedicated completely for a certain role. Whereas here DBMS is doing that kind of stuff. The DBMS task is to control the load, buffer management, and if the database is located in some remote service, if you want to still have a connection with all the resources, yes, that can be done and scheduled by DBMS alone. But the overall picture can be grouped and it has been facilitated by operating system. Here there is no question of operating systems takes a complete picture of DBMS or the DBMS completely overrule the operating system. Either of that is not possible here. So we need to understand that DBMS is sole responsibility of scheduling some of the operations in the memory, but in some cases in page replacement, in some say the page is get overloaded and the block is get delayed because of some internal reasons. In those cases the operating system role is somewhat helpful in achieving the task. So this needs to be a bigger context. And if you go in-depth analysis of query optimization, in that class we are going to unreveal and unravel many of the aspects of how this is being get done. So in the coming classes we will go and talk about that, and the logical and physical data independence we are going to deal more on this. What is logical data independence and what is physical data independence. So on that aspect we are going to talk about the contention rate between the conceptual design and the physical design. How far this is being leveraging with one another, in what way they are conflicting with the memory slots and the database design. So those things we are going to discuss in logical data independence and physical data independence. So with this we stop this lecture, and I hope that you have a good understanding on these two things. We believe you understood that what is the importance of DBMS and operating system in deciding a crucial factor of storing the data in the database. Thank you so much for your patient listening. We will see you in the next lecture. Thank you.